Here's our last example. And this is an example where you have to use multiple right angle triangles and build information onto each triangle through problem solving. So this is actually a pretty common type of problem solving method because there are a lot of, whether they're geology people, this is a rock question, whether they're city planners, architects, if they are tree people, if you're going any into the lumber business, anything like that in biology, you always have to approximate heights of trees in order to gauge age and things like that. These are all methods used. So this is actually applicable compared to some of the other math we do. So here we go. There is a rock pillar, and a geologist wants to know how tall is this rock pillar. But the problem is that the rock pillar is located at an unknown distance from a point on shore, and like, how would you, measuring this length is really, really difficult because you've got a differential as far as your substrate is concerned. It makes it really difficult to know what exactly is that length. So what the geologists will do is they use a theodolite, which is just a fancy angle mapper, and it literally is calculating, like, here's your horizontal. If I move the little camera up, you can see that your degrees change. So you're creating an angle that you know at a specific point on the ground. So let's get rid of the theodolite. What they decided to do is they decided to set this theodolite up at C. So they're setting up their situation here. That is their solid spot. And then they're using the theodolite to determine that there's an angle of elevation to the top of this geological figure of 28.5. Awesome. We don't know anything else about this triangle, though. Like, we don't know how far that is. We're trying to find how high that is. And this is a really hard measure to find. So what they do is they create a second triangle, a right triangle. And they mark, based on where they are, they create a baseline that is perpendicular to what they're trying to find. So this is straight across. They've created a 90-degree perpendicular, and by doing this, they're able to make like a flat triangle. This triangle's up in the air, this one is flat on the ground, and they can measure this side. And they can measure an angle. So they can create enough information in this triangle to find a piece of this triangle, and then you have to use that piece with what's given to find your height. So they said length of this is 10 meters. And that angle CDB is 56.4. That's on there for us. So game plan. We first have to find this side length. Then we have to switch triangles using that same side length, and then we have to find our height. Okay, there's our game plan. So I'm a fan. You know I like diagrams. You know I like to see what's going on. So my first triangle is this one. Oh, my sweet baby Jesus. Giving up the dream. Let's make it look the same. Okay, there it is. It looks like that. So I'm going to straighten that back out. Or not. And start working with it. So we know this is our 90-degree angle. This is 10 meters, and this is 56.4 degrees. So we want to label our sides, height, going across from the angle is op, right beside the angle is adjacent. We are using adjacent and trying to find op, so we have to use OA. So cat, hoa, oa. Okay, so we have to go tan of the angle, 56.4, equals opposite. Good, that's what we're trying to find. X over adjacent. Okay, created a question we were just working on. Tan of 56.4 is 1.5051 equals x over 10. Multiply both sides by 10. Boom. We get 15.05. 15.05 meters equals x. So now we have to switch triangles. Now we're on to this up triangle that's standing up and down. So we know now, because they share this side, that 15.05 also applies to the up and down triangle. But let's draw that one out. This is, that's the height that we're trying to find. We know this is 28.5 degrees, and we just found out that this is 15.01 meters, 05, sorry, meters. Okay, so our given angle is there. Label our sides. Hype, op, A. We have to use tan again. Tan of 28.5 equals opposite over adjacent, 15.05. Tan of 28.5 is 0.532, oops, 30. 0.5, no, Megan, 0.5430 is x over 15.05. And then we multiply by 15.05 on both sides. .17. Therefore, the height of the rock thing is 8.17 meters. Boom.